All right, guys, we have this video here to help us work through every single question on the practice test, sections 5.3 to 5.7. Yep, this is pretty much the chapter 5 test. Let's begin with question number 1. On this particular question, it says, select all correct answers below. So it's a multiple choice, but it's not select one, you select multiple ones, all the ones that are correct. Tip, try looking at it as if it were a quadratic, or you could graph it. So if we were to take Desmos and type this in, and you zoom in appropriately, you'll see that it has the answers x equals -2 and x equals +2, because after all, the answers are the x-intercepts. So let's keep that in mind, -2 and +2. So knowing that these two are the answers, you could plug in the +2 and then plug in the -2 with synthetic substitution. So this is a 1 on the leading coefficient of 1 on the power of 4. There is no r to the power of 3, so you put a 0 to hold that place. There is a leading coefficient of 2 on the r squared. There is no r, but there is a -24. So you would be doing this synthetic substitution to get a depressed polynomial. After all, we want a quadratic. We're comfortable with quadratics. We're not really comfortable with quartics or cubics. So as you go down, you combine 1 plus nothing is 1. As you go up, you multiply. 2 times 1 is 2. As you go down, you combine 0 plus 2 is 2. As you go up, you multiply. 2 times 2 is 4. As you go down, you combine. 2 plus 4 is 6. As you go up, you multiply. So 2 times 6 is 12. As you go down, you combine. 0 plus 12 is 12. As you go up, you multiply. 2 times 12 is 24. And we are happy that we got a remainder of 0, or the output 0, because we know we did the right work. If you did not get a 0 out here, then you know you did some type of wrong work, so these numbers would be wrong, so this depressed polynomial would be wrong. So you want that 0 right there. Anyways, that is barely plugging in the number 2, and we could get this depressed cubic polynomial, but we would like a quadratic instead. So instead of rewriting this as a x to the third plus 2x squared plus 6x plus 12, we're going to move on to the next answer that we know, which is a -2. So let's plug in a -2, and you could rewrite these numbers if you want, or if you'd like, you could just put the little box right here, -2, put the line right here, and just work with those blue numbers just like we did before. Okay, so as you go down, you combine. 1 plus nothing is 1. As you go up, multiply. -2 times 1 is -2. As you go down, combine. 2 plus -2 is 0. As you go up, multiply. -2 times 0 is 0. As you go down, you combine. 6 plus 0 is 6. As you go up, multiply. -2 times 6 is -12. And once again, we are happy to see that the remainder is 0. And that's always true. If you plug in an answer, your remainder should be 0. If you divide by its factor, the remainder should be 0. The output should be 0. Anyway, what do we have here? We now have a quadratic. This is x squared plus 0x, which you're not going to put, plus 6. Okay, so what we have here is a quadratic binomial that we need to solve. And of course, how do we solve it? We set it equal to 0. And you don't even have to use a quadratic formula. You don't have to use factoring. Let's just subtract 6, and you will have x squared equals -6. Okay, so let me write it over here. X squared equals -6. To get rid of the square, we're going to square root, and you will get x equals plus or minus. The negative inside the square root is going to come out as an I, and the square root of 6, there's nothing to do with it. So there is your answer. X equals plus or minus I square root of 6. So this fourth degree equation actually has 4 answers. 2 of them are real. We saw them on the graph, +2 and -2. The other 2 are imaginary. The positive I square root of 6 and also the negative I square root of 6. Now that was one option, typing it into Desmos, which I'll be honest with you, it does take a while typing it in, and this also takes a while. So the tip I gave you right here, that's another option. It says try looking at it as if it were a quadratic. Or you could graph it, but let's try to look at it as if it were a quadratic. Let me zoom in. So what I'm saying is I'm going to make it look like a quadratic equation. It'd be nice instead of the r to the fourth, it's x squared, right? Instead of 2r to the second, it's x, right? That'd be nice. So we could replace, if we wanted to actually visually show it, replace r squares with an x, right? Or you could just plug in the r squared. How do I know that? Well, I got to think what value belongs in here that when you square it, it gives you this first term. You don't want to be changing the equation. You actually want it to stay the same, right? You want it to be an r to the fourth. So what squared would give you an r to the fourth? That would be an r squared, okay? Which means over here, you'd also have an r squared. And that makes total sense because that was already an r squared right there with the 2. And then, like I said, you could, if you wanted to, replace your r squares with the x. That way it'll look like a quadratic equation, x squared plus 2x minus 24. But if you don't want to do those extra steps, you could just pretend that you had an x squared and an x, which means you have an x right here and an x right there. But obviously we don't have x's. What do we have? We have r squares. So those r squares are going to go right here. And then we could think, what times what is negative 24? That if you add together is the b value, the middle term, positive 2. So if you need to, make a list. How could you get negative 24? Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6, and that's about it. Those are all the possible combos. Now, which of those combos combines together to give you a positive 2? The negative 4 plus 6. Negative 4 plus 6. All right, so we have factored it, and it was an equation set equal to 0, so we would still have to set it equal to 0, and we'd have to split them and solve using zero product property. So splitting them, r squared minus 4, I'm just going to write it down here. R squared minus 4 equals 0, and r squared plus 6 equals 0. So for the minus 4, I would add 4, and you will have r squared equals 4, and then you would square root, and you would get the answer that we saw on the graph, r equals plus or minus 2. Okay, that was the answers, the x-intercepts that we saw. When you square root 4, anytime you apply a square root in an equation, you have to put a plus or minus in front of your answer, and the square root of 4, the answer is 2, so you get plus or minus 2. Those are your 2 real answers. Over here is where you're going to get your 2 imaginary answers. Just like before, subtract 6, you're going to have r squared equals negative 6, and when you square root both sides, you'll get the r equals, the square root of a negative is really I, and the square root of 6, you cannot do it, so it would be r equals, I forgot the plus or minus I square root of 6. So those are your 4 answers, and you could compare the amount of work. I would say they both take an equal amount of time. I'm not really too sure. Maybe this way is faster because you don't actually have to use Desmos, but it's totally up to you. I've shown you 2 methods, 2 ways of doing the same problem. Number 3, given that x plus 2 is a factor of the polynomial, identify all the other factors. And I apologize, I had to white this out and put a 6 right there. That's supposed to be a 6. Anyway, let's find the other factors that are giving us a factor. So I say go to Desmos, type it in exactly as you see it here. You could put y equals x to the 4th plus 5x to the 3rd, or you could just type it in exactly like this. Desmos already knows that it's going to be a function, so you don't have to put the y equals. But when you type it in correctly, you'll see this. And of course, you could clearly see that you have your 2 answers, x equals negative 3 and x equals negative 2. So let's keep that in mind. We have our 2 answers, negative 3 and negative 2. Now, if you wanted to take a moment and think about this, this is a 4th degree equation, and it only crosses at these 2 locations, and they cross like a line. They don't do they don't touch, which would give you a duplicity of 2. They don't squiggle, which might have a duplicity of 3. These are just crossing right through. So you have a single answer, x equals negative 3, a single answer, x equals negative 2. So you must have 2 more answers that are imaginary, because there's no other place where it crosses the x-axis. So we have 2 real answers, one's negative 3, one's negative 2, and we have 2 more answers that must be imaginary. And looking back at our problem, they're not even asking for the answers. They're not asking for what are the answers, x equals negative 2 or x equals negative 3. Those were the answers, negative 2, negative 3, x equals. However, they are asking for the factors, right? So if the answers are x equals -2 and x equals -3, where did they come from? They came from the binomial +2 +2. They came from x plus 2 equals 0. They came from that binomial. And this other one, +3 +3, this answer, x equals -3, came from x plus 3 equals 0. Okay, so those two are factors. By the way, they already gave us that one. So there it is. But they want us to identify the other factors. So we know x plus 3 is a factor. So you would select this one. But we need to find the other ones, right? And we knew by looking at the graph that they don't cross at actual real locations. So the other two solutions must be imaginary, which means that we should have a binomial that produces those imaginary answers. So what are we going to do? We're going to take the answers that we have, the actual x equals -2, and plug it in with synthetic substitution. So here's my -2 that's going right in. My coefficients, power x to the 4th has a leading coefficient of 1, x to the 3rd has a leading coefficient of 5, 7 on x squared, 5 on x, and 6 as the constant. So as you go down, you combine. 1 plus nothing is 1. As you go up, multiply. -2 times 1 is -2. As you go down, combine. 5 and -2 is 3. As you go up, multiply. -2 times 3 is -6. As you go down, combine. 7 minus 6 is 1. As you go up, multiply. -2 times 1 is -2. As you go down, combine. 5 combined with -2 is 3. As you go up, multiply. -2 times 3 is -6. Of course, the remainder is 0. That's what we need. That way, I'm pretty positive. I'm rest assured that I did this right. I know that these values are correct. That was barely one answer, x equals -2. We're now going to use the other answer, x equals -3, by plugging it in as well. And again, instead of me rewriting these numbers over again, I'm just going to put that -3 right there. And again, start working with the numbers right here. The 1 plus nothing is 1. As I go up, I multiply. -3 times 1 is -3. As I go down, I combine. 3 and -3 is 0. As I go up, I multiply. -3 times 0 is 0. As I go down, I combine. 1 plus 0 is 1. As I go up, I multiply. -3 times 1 is -3. And once again, I am happy that my remainder, my output, is 0. That means I did everything correctly. So I have these numbers, and this is my depressed polynomial, which is now an x squared plus 0x plus 1. So I am good with solving quadratics. And if I wanted to solve it, I would put equals 0, and I would have -1, which would give me my two imaginary answers, x equals plus or minus the square root of -1. But I'm not going to do that. Why not? Because they're not asking for answers. They're asking for the other factors. So we already knew that x plus 2 was a factor, right? We already knew that. And notice it's not there because they told us that x plus 2 is a factor. But we also found out that x plus 3 was a factor by graphing it. And we also got our depressed polynomial with that answer, the -3 when you plug it in. We got this depressed polynomial, and that's the other factor. Here it is. So these are the two answers that you would select. Select all the true statements. A 5th degree polynomial can only cross the x-axis 7 times. That is absolutely false. Why is that? A 5th degree, that means that you have a maximum of 5 answers, which means that you have a maximum of 5 x-intercepts. There is no way that you have a x to the 5th degree power polynomial that has 7 answers, that crosses the x-axis 7 times. Now, if it would have said a 7th degree polynomial can cross the x-axis 7 times, you would say, yes, that would be a true statement. But there is no way a 5th degree can cross it 7 times. So don't select that one. Next one says, the x-intercept of a polynomial function are real answers. That's absolutely true. We know that x-intercepts are answers. Now, the only difference here, it says real. That's because we're talking about answers that are not imaginary, right? Obviously, you could have imaginary answers, but you are not going to see those as x-intercepts. So this guy is absolutely true for sure. That one, select that one. Moving on. A 7th degree polynomial with a positive leading coefficient will have its end behavior in quadrant 1 and quadrant 3. Okay, so don't get thrown off with the 7th degree. The fact is, you're talking about an odd degree polynomial, okay? An odd degree polynomial. And the leading coefficient is positive. So if you know you have an odd degree polynomial, leading coefficient positive, and you're thinking, well, what quadrants will this graph end up at? Remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. And we are talking about an odd degree. Again, who cares that it says 7th? We're talking about odd. Right? Now, if it would have said 4th degree, then it would have been an even. And we should know how odd degree functions behave, how their end behavior is on a graph. Think of the easiest odd degree function. The easiest odd degree function, y equals x, right? You know that it says to the power of 1 right there. So this is the easiest odd degree function. And that's, you could even think of y equals mx plus b on that. It rises 1, runs 1. So this line is the diagonal that goes like that. So where's the end behavior? It's in quadrant 1 and quadrant 3. So any odd degree function will have its end behavior in quadrant 1 and quadrant 3. Again, end behavior is just where it ends up. Of course, other things will happen in the middle, right? But it'll end up in quadrant 1 up here and quadrant 3 down here. So an odd degree polynomial with a positive leading coefficient will have its end behavior in quadrant 1 and 3. That's absolutely true, 1 and 3. Now, what happens if it had a negative sign? Then it would reflect it over the x-axis and it would have it in 4 and 2, 2 and 4. So keep that in mind, because I always, on the test, go back to these problems and change one word or two. Maybe I changed odd to even, right? Or maybe I changed quadrants 1 and 3 to 2 and 4. I don't know, but it's pretty much the same exact test, just with a couple of different words changed. So this is correct. Moving on. If you divide a polynomial by one of its factors, the remainder will be 0. That is an absolute true statement. If you divide a polynomial by one of its factors, the remainder will be 0. Even if you take the number 12 and divide it by one of its factors, like 4. If 12 divided by 4 is 3, there is no remainder. That's always true. If you divide a polynomial or even a number by one of its factors, the remainder will always be 0. Let's move on to question number 5. Find f of -3. So you could manually plug in a -3 on all these, or you could use synthetic substitution. And they want you to plug in a -3. So put that -3 inside the box, and you need a list of your coefficients of every single power represented from the highest down to the lowest down to the constant. So you have 5. It's obviously missing x to the 4th. So let's begin with the number 2, the coefficient of 2. And then we have no coefficient representing the x to the 4th. But then we have a -3 on the x to the 3rd. We have a 50 on the x squared, a -15 on the x, and a -100 as the constant. So as you go down, you combine. 2 plus nothing is 2. As you go up, you multiply. -3 times 2 is -6. As you go down, you combine. 0 plus -6 is -6. As you go up, you multiply. -3 times -6 is +18. As you go down, combine. -3 and 18 is 15. As you go up, multiply. -3 times 15 is -45. As you go down, you combine. 50 minus 45, that is 5. As you go up, multiply. -3 times 5 is -15. As you go down, combine. The -15 and -15 is -30. As you go up, multiply. -3 times -30 is +90. As you go down, you combine. Why did I put 99? It's supposed to be 90, sorry. 90. -100 plus 90, that is -10. Now, don't think, oh, why didn't I get a remainder of 0? No, this is not synthetic division. This is synthetic substitution. And we're not trying to find x-intercepts on the graph or anything like that. Right here, we are simply plugging in -3, and whatever we get out here is our output. So you type in -10, hit enter, and that'll be the correct answer, okay? Number 6, we have a 4th degree equation. They want us to find all solutions. We got to select all the ones that are true, okay? And it says a graphing device helps. So let's do that. Let's go to Desmos and type this in. This will take a while, and you have to type in carefully. If you mess up on you put a minus instead of a plus, you're going to get the wrong answers, right? So type it in carefully. You'll see that your answers are x equals -2 and x equals +1. Those are your two answers. So far, we have those two answers. And let's say I did have a quadratic equation, a degree of 2, then two answers, that's enough, I'm done. But I know I have a 4th degree, and I know I need to find another two answers because the graph, it just crossed through the x equals -2. It just crossed through the x equals 1. That means that there's no duplicity. Like for example, if it would have come down touched and then come down touched, then both of these would have the duplicity of 2, giving you a total of 4 answers. But we know that that's not the case. So we need to actually find the other two answers, which means that they're imaginary because nowhere else does this graph cross the x-axis. So let's find those imaginary answers, knowing that we have two answers already, -2 and +1. So let's start with the answer +1 and let's plug it in with synthetic substitution, or the remainder should be 0. So I'm plugging in the 1 into the box and I'm going to do the list of coefficients. Again, all I did was take the 1 in front of the x to the 4th and put it right there. 1 in front of the x to the 3rd, the 16, the 18, +18, and the -36 right there. There's my list. And now I'm going to do synthetic substitution. And as I go down, I combine. 1 plus nothing is 1. As I go up, I multiply. 1 times 1 is 1. As I go down, I combine. 1 plus 1 is 2. As I go up, I multiply. 1 times 2 is 2. As I go down, I combine. 16 plus 2 is 18. As I go up, I multiply. 1 times 18 is 18. As I go down, I combine. The 18 plus 18 right here is 36. As I go up, I multiply. 1 times 36 is 36. And of course, I am happy to see this 0 as my output, the 0 as my remainder. Again, because this is an answer, so that means that my output has to be 0, my remainder has to be 0. You could even think of this in terms of coordinates. What is the coordinate of this solution here? The input is 1 and the output is 0. And that's exactly what these are on synthetic substitution. This is your input, this is your output. So this is the coordinate 1, 0. So this makes total sense. Again, the whole purpose of plugging in the answer is not to get out the 0. That's just to make sure that you did this right. But the purpose is to get these numbers because this is a depressed polynomial. And once you get it to a quadratic, you could either use the quadratic formula or hopefully you're able to factor it and find those answers with factoring methods. Anyway, we still have another answer. The other answer is -2. So what I'm going to do is simply put my box again right here and put the -2 right there. That way I don't have to rewrite this list. I'm just going to use this list right here. And again, same deal as before. As I go down, I combine. 1 plus nothing is 1. As I go up, I multiply. -2 times 1 is -2. As I go down, I combine. 2 plus -2 is 0. As I go up, I multiply. -2 times 0 is 0. And as I go down, I combine. 18 plus 0 is 18. As I go up, I multiply. -2 times 18 is -36. And once again, I'm happy because the remainder is 0. And once again, that's really just knowing your coordinate has the x value of -2 and the y value of 0 because your input -2 gave you the output 0. That came from the answer that we saw on the graph. Anyway, we now plug this one in to get our depressed polynomial, and now we do have a quadratic x squared plus 18, right? The 1 is on the x squared. There is no x, so I don't have to put plus 0x, so I'm just going to put plus 18. And this is the factored form of this part of the polynomial. So since it is equal to 0, if I did write it in completely factored form, you'd split them all up, right? So you should have, you could imagine this in parentheses, you would have x minus 1, and that's when you split it and set it equal to 0, that's how you get the x equals 1. You could also have the x plus 2 in parentheses, but when you split it and set it equal to 0, that's where you get the answer x equals -2. And this answer, when I set it equal to 0, what will it give us? And that's what we're looking for because it's going to be imaginary, one of those. So I need to solve this thing. I'm going to subtract 18. So what I have is x squared equals -18. And in order to get rid of a square, I square root. But when I apply a square root in an equation, I need to put a plus or minus in front of my answer. Now, my answer is, well, I still need to figure that out, but I do have a negative 18 right now. And that negative sign is going to come out as an I. So I really have x equals plus or minus I square root of 18. And for my final step, I need to simplify the square root of 18. So what is the square root of 18 reduced down to, or simplified down to? 18 is not a perfect square number, but I could rewrite it with multiplication to get a perfect square number, like 9 times 2. That way when I split it, I'll have the square root of 9, which is 3, and the square root of 2 stays the square root of 2. So my final answer is going to be x equals plus or minus the I with the 3. I'm going to put the 3 first, then the I, and then the square root of 2. Once again, 3 square root of 2 goes right here. This really becomes 3 square root of 2. So you have I 3 square root of 2, but instead of I 3 square root of 2, I'm going to write it 3I square root of 2. So there is my other answer, which is this one, and you would have to select all 3 to get this question right.